Hi guys, I'm going to look at Unit 5B, Section 6 again. I've gotten some questions from some people. They're having a hard time getting this done. I gave you the first 2 pages of homework. So you have numbers 1, 2, 3, 4, and 5. We didn't get to 4 and 5, I don't believe, in class. But there's other pages, 6, 7, 8, 9. So I'm going to do number 6. So you might have to print that out. So we're going to do number 6 from the homework. But before we do that, let's review what we talked about when it comes to word problems. The first thing is we most of the time only need to look at the first quadrant. And I want you to think about why that is. And if I were to ask you the question, if I was in class, I would ask for someone to tell me why that is. And if you can't answer that question, you really need to think about it, and you need to make sure that after I go through this lesson that you can. So I'm going to ask questions just like I would in class, but you need to think about the answers because you don't have your normal people in class who usually answer these questions. Okay? So the reason we only use the first quadrant is we're really talking only about our positives. In the first quadrant, the x and the y's are all positive. So in most cases, as I told you with the parabolas, a lot of the problems are going to be time on the x-axis and height on the y-axis. Now you have to be able to switch back and forth between height and time and x and y. And so what I'm going to do is review where the math relates to the real life problem. So I'm looking at number 6, and she said, Lana hit a volleyball into the air with initial velocity of 24 feet per second from initial height of 3 feet. Okay, so this one is taking into account they're not hitting it off the ground. She's not hitting it overhand. She must be hitting it underhand. And so we know that the volleyball does not start at 0, 0. It starts somewhere at 3 feet. Okay, she hits the volleyball up into the air and it comes back down. Okay, now let's talk about all the parts of a parabola and what that means in real life and what that means related to math. So the initial height, or the starting height, is also in math language going to be our y-intercept. If it's our y-intercept, that means x is 0 at that point. Okay, so that's the math, and the real life is initial height. Okay, let's think about the vertex. The vertex can be a maximum or minimum. A lot of times we're talking about trajectories, it's going to be a maximum. Okay, so remember, to find a vertex, there's a couple ways you can use your graphing calculator. You can use x equals negative b over 2a to get the x value. There's a couple different ways you could do this. In real life, the vertex is going to tell me when I'm at my max height and what my max height is. Okay, so if I'm asking for max height, I'm asking for the y value of the vertex. If I'm asking when the ball hit the maximum height, then I'm asking for the x value of the vertex. Now remember, these problems are written in with real life thoughts in mind. If you get a max height of 50 feet, this is a volleyball. I don't know, is that reasonable? Does that make sense? Is it going to be in the air for 30 seconds? If you have a ball that's in the air for 30 seconds, something else weird is going on, okay? So we're talking about a ball. Now, if we were talking about a bullet being shot out the end of a gun, that would change our trajectory. That would change how long it was in the air. So you have to really think about it and relate it back to the word problem. Now, here's the big idea that we've been talking about the entire lesson, all of 5B. A lot's happened since then, but that's this point right here. And this is when the parabola crosses the x-axis. And we have a lot of different names for that in math. Okay, the first one, and I'm hoping right now you're saying them out loud: solution or solutions, zeros, that's how that shows up in our graphing calculator, and roots. If we have to use a quadratic formula, a lot of time I might refer to it as roots. So on the SAT or in my class, we may be switching back and forth. What that means in real life is when does it hit the ground? Now, if it's hitting the ground, what would the height be? In this case, if it's hitting the ground, the height is 0. So we know it's hitting the ground, the height is 0. Okay, so that was basically what we talked about. You should already have that in your notes, but in case you missed the day that I taught that, that was kind of what our notes were, is just looking at this picture and thinking about what it means in math and in real life. So let's do number 6 completely as an example. So again, we have Lana hitting the volleyball, okay? And we're going to use the equation, the original equation from the top of the page is h equals negative 16t squared plus the initial velocity plus the starting height. Remember, the t stands for time, the h stands for the height at a specific time. So the problem has to give you some things here. We already have the negative 16t squared. The initial velocity is in the problem, and that says an initial upward velocity of 24 feet per second. Don't forget your t on that. And then it says an initial height of 3 feet. Okay? So there's our equation. And I just got all that information from the word problem. Now, the question is, could I factor this? How do I figure out a solution? How do I know when this hits the ground? Well, there's a lot of ways to figure out solutions. The first way that I always look for to see if this could be easily factored. And at first I was positive that, oh, this looks good because 3 goes into 24, but 3 does not go into 16. So factoring doesn't work here. So that's usually my first go-to in a word problem, is factoring. So I'm going to cross that out. If that doesn't work, I generally don't jump to completing the square. I then go to quadratic formula. Now, for some reason, a lot of you seem to have forgotten this. So don't worry, I will be putting a link on my Canvas page with the song so you can remember it. It's x equals negative b plus or minus the square root of b squared minus 4ac all over, this is the part a lot of people forget, over 2a. Now, before we start these problems, we always want to look at the discriminant so we have an idea what our answers are going to be. Are we going to have one answer, two answers, or no answers? And so we're going to look at the discriminant first. So there's the discriminant. I highlighted it in blue. So I'm going to use the discriminant to find this answer. But before I do that, let's do our A, B, and C. You should all be really good at this, but I still have a few of you that keep wanting to put the t on there. A is negative 16. B is 24. And C is 3. Okay? So let's deal with our discriminant first so we know how many solutions we're looking for here. So this is where we kind of have moved into the math world. We're still talking about a volleyball in the air, but we have to use the math to talk about the rest of this problem and to know how to set up our graph. So I'm going to do b squared minus 4 times a times c. So it's 24 squared minus 4 times negative 16 times 3. This is where I get out my calculator and I punch it in exactly the way I see it here. I use the parentheses where I need to. I make sure I'm using negatives where they're appropriate and subtraction where there's appropriate. I'm going to figure out what the discriminant is here. And I got 768. What that means is that I will have 2 real solutions. Now that's math language. What we have to decide is when we get those real solutions, do they really match up to the problem? So we have to think about it. We have to use our brain. We have to go back to it. So I'm going to see 2 real solutions, but then I'm going to need to see if they make sense with this word problem. So let's finish out the problem. We have x equals negative b plus or minus the square root of the discriminant, which we just figured out, all over 2 times negative 16. So I just filled in the rest of the equation, the quadratic formula, okay? As I've told you, so this is my substitution step, and we talked about this before, this should be in your notes. Then we're going to simplify. When we simplify, I put negative 24 plus or minus. Now I might check to see, is 768 a perfect square? It's not, so I'm just going to leave it that way. Square root of 768 over negative 32. Now I'm going to solve. Well, I already know that in math world, there's two solutions here, so I'm going to solve it twice. Negative 24 plus the square root of 768 over negative 32. And then I also have negative 24 minus the square root of 768 over negative 32. Okay? I do the top first. Remember, if you try to punch this in without the appropriate parentheses, it doesn't work. So I always recommend get the top answer, so negative 24 plus the square root of 768. Write that down, 3.71, and then divide that by negative 32. My answer here is negative 0.12. Let's leave that for a minute and let's do the other answer. So negative 24 minus second square root 768. So I got negative 51.71 over negative 32, and then I divide by negative 32, and I get 1.62. Now I'm going to ask you a question. There are two solutions here mathematically, algebraically. Only one of them makes sense with the problem. Which one makes sense with a problem, and why does it make sense with this problem? We have to go back and think about, what did we just solve for? Well, in math world, we solved for x. But back in this problem, our x-axis is actually time. And so negative 0.12 doesn't make sense because it's negative time and we're not going back in time. So the only answer that actually makes sense in this problem is 1.62 seconds. So that's when the volleyball hits the ground. So let's start graphing that now. So we already know what our x and y, we have time and we have height. I'm just looking if I think I did this problem. So okay, so we have time, and that's in seconds. And we have height, and that's in feet. Okay? The next thing is, I told you I need to know what's going on in this problem. I don't want to read the words. If I'm a mathematician, I'm looking at this graph, and it should be enough that you label it enough that I know what's happening. So I'm going to put hit volleyball, or volleyball hit by someone, so that I know we're talking about a volleyball that was hit. Now I know my time has to reach 1.62 because the volleyball is in the air for 1.62 seconds. So I have to decide what to count by. Well, I'd already done this problem, but this is where I think some of you want to just sit and wait. I'm only doing one problem with you. I would either count by 2/10 or 1/10. I have to kind of test it to see what works. I already did this problem in my book, and I know that I can count by 1/10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 1 second. 1, 2, 3, 4, 5, 6, 7, okay? And remember, you don't have to put a number on every single thing. That gets a little confusing. So we could actually mark that it hits at 1.6. We got 1.62, so I'm going to go 1.6. 1, 2, 3, 4, 5, 6, and a little bit. That's where we hit the ground. That's where our parabola ends. Now, the next thing we have to figure out is, what's the vertex? So I've taught you how to do the vertex. You're going to pick up your calculator. You're going to go to y equals. You're going to put in the equation. You're going to hit graph. If you can't see the graph, and I'm not going to tell you this part, this is where you have to use some logical thinking. You're going to go to window, and you have to change it so you can actually see your graph. I will give you a hint. After you fix your window, you can go to second. And you need to fix your window so you can see the vertex. If you can't see the vertex, you can't do this next part. You're going to go to second trace. You're going to look at the calc menu, and most of you know how to do this, and we're going to do number 4, max. You pick your left bound, hit enter, You right bound, and you hit enter. And then when you see the word guess, you hit enter one more time, and that's going to give our vertex. So in this case, we get a vertex of 0.75 and 12. Okay, now you got to go back and think, what does that mean in real life? That means at 0.75 seconds, the ball was at its max. And the max height was 12 feet. So now I know my y-axis needs to be able to reach to 12 feet. So I have to decide what I'm going to count by. And I figured that out, that I can count by ones, and I should fit 12 on here. So I'm going to count by ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Now the first thing I need to put on here is where did the ball start? And it says that in the problem. The starting, you can find that in the problem and you can find it in your equation. Way back at the beginning here, here's our starting time. It also says it in the our starting height. And we started at 3 feet. We did not start on the ground. So I'm going to put a dot there. That's my starting height. We know, because we put this in our calculator, at 0.75, we reached 12 feet. So I'm going to go 1, 2, 3, 4, 5, 6, 7 and a half, and I'm going to put 12. Now I can connect my volleyball path. It goes up and then it comes down. And that's how I finish the problem. Now I might ask you, at what time was the ball at 5 feet? Well, the ball was at 5 feet in two places. The ball was at 5 feet here. And so that's 1/10 of a second. But it was also at 5 feet when on its way down. Now this isn't as exact, but it's right here. So there are two answers to that. There's 2 times the ball is at 5 feet. And you have to really think through these problems. So I really want you to try, if you haven't finished the worksheets, to finish up these worksheets when you have time. So hopefully that answered some of your questions. I'm, again, not sure what's going to happen, but that's for lesson unit 5B, section 6. That kind of gives you the notes and an example problem. See what you can do with the rest of the problems.